So we're going to talk about this little guy here. He is a 1.7 amp, 24 volt DC power supply with 100 to 240 volts AC input. This does not have any power on the output. So we're going to tell you why it doesn't. But I'm going to explain the circuitry a little bit before we get into why and how and where. These two little brown guys here, or red, depending on your color of taste, they're fuses. This is your bridge rectifier right here. It's a little black guy. It's a large capacitor. You have your transformer here. You got a little MOSFET. You have your switching diode right there and two filter capacitors on the output. This is the chip that control the frequency on the output of the switching power supply. And that's basically how that works. So you have two fuses, and this fuse here is good. This fuse here is not good. This is your DC and negative. That's your positive and negative on the bridge. It's 300 ohms, 366 ohms. Here's your AC coming in, 367. Here's your AC in the negative, or the positive. Actually, yeah, positive, 0 ohms, and 0 ohms. So that thing is shorted, that diode, that bridge. I'll go to the MOSFET. The MOSFET is reading in the mega ohms. That's reading to the 367 ohms. I'm hoping the MOSFET is good and changing the bridge and the fuse will take care of it. Additionally, you have to take and do a little bit of visual inspection. As you can see, maybe not, there's a little thing down here by my thumb where the capacitor is, and it just kind of, it's bad. So the biggest thing is how we're going to get this out. And you're going to have to take this nut off. You have to take this nut off. You're going to have to bend this tab back. And I believe that's all there is to it. And bend this little tab back here, and this heatsink will come up, and you'll be able to get to your capacitor. So we will take and go ahead, and I'm just going to bend that up just like this. I'm hoping we don't have to do any soldering or desoldering for this, because that's going to be a pain. There's one screw here, there's another screw here. So I'm going to get the Phillips screwdriver out and remove these two screws. That's too large. That might fit it. Yep. I'll show you the capacitor here in just a second. I may have to take and loosen the nut. I don't have my pliers with me. This pair of cutters will work just fine. Not sure what that screw is there for. Must be a ground tab or something. That's a little weird. Never seen that kind of stuff before. It's different. We'll get the rest of this out, and I'll see about taking this off. I did want to point out, when you take this one out, do not lose that plastic insulator. It is important. It will isolate the screw from touching the tab to this. So you don't want to, do not want to forget that little plastic guy right there, because things will go boom. We don't like going boom, do we? I'll loosen this screw up here, and this whole heatsink, it just comes off like this. It was not expected, so that's why I kind of had to take another break into the video. I think that'll be enough to take and get to the capacitor and to the bridge and the fuse. I've had a little bit of help for the flat tip screwdriver to get that out. We would take and heat up a soldering iron. And it'll be these 2 points here for your capacitor. You can get them loose and get them out. Sam Axe On. That's a very cheap Chinese brand that they use commonly in televisions that goes to the dumpsters after they fail. Essentially where this was headed before I decided I was going to take it and fix it and make a video for it. I'm just going to heat up the leg here, the solder joint. I don't think we can be able to get, yep, we'll be able to stretch it. Now, if you have a solder sucker, this would be ideal to try to use a solder sucker. I don't have one. I really don't see the need for me to have one because I don't actively do a lot of repairs. I just take and bend back the leads of the capacitor. I have never had any problem with circuit board damage or anything like that. Some people kind of frown on this, and well, that's just who they are. They frowned on it. A lot of my repairs, I do know that people will watch is because they've found this being a problem with their product and they're just having an issue and they want to figure out what it is. Now you can see right there that the electrolytic fluid has came out. Probably was the root cause of the problem and to begin with. Another essential item I have is this toothpick. And what you can do with it, lead does not take and stick to it. Solder does not stick to wood. And you can take and use it, poke a hole. You know, if you have to MacGyver yourself a repair, that's what you gotta do. Now you have 2 clean holes, and toothpicks cost like, I don't know, $2 for 100 of them. Throw this in your campfire next time you want. Reuse it. Just don't use it for your own mouth. Alright, so we have parts. Here's the bridge rectifier. Now parts altogether was like $6 and I don't know, 60 cents. KBP06G is the bridge. The capacitor is 150 microfarad, 400 volt. You can get whatever brand you feel like is needed for you. I got, let's see, what did I buy? KHF, which is probably a cheap Chinese crappy one, but if it lasts for another couple of years, well, got my money worth out of it. Here is the fuse. Nope. Here's the fuse. The through hole is MRT 3.15. That's what it looks like. So, I guess the best thing, if you did have a solder sucker, would be to take the bridge out. You don't necessarily need it, but it would help. Otherwise, you want to take and put a solder bridge all along that bridge rectifier and just kind of persuade it to come out. And all I'm doing is going back and forth between each of these pins and heating up the solder joints. And there you go. It just fell out on its own. We'll use the same toothpick method and heat up the solder joint and poke it through. I was taught this trick by an older technician, so hopefully some of you guys are enjoying that. We'll take this fuse out here same way. It just fell. Alright. Put the bridge in first. Well, the fuse in first, and then we'll get to the bridge. Try not to take a long video here. You can see that the solder blob might be on the top of this. You can always take and pick that off. Or maybe not. Maybe it's best to work from top to bottom. Yeah, we'll do it that way. Work top to bottom, and you don't have to worry about solder blobs. Okay, the rest of that looks okay. Now to put the fuse in. It does not matter how this fuse goes in. They are not directional. Kind of wanted to tack it, but tack it into place. That one. Here's the old bridge, the fuse. Here's the new fuse, new bridge. I use the same part, KBP06G. On the board, you'll see a plus and a minus. You'll see a plus and a minus. The two centers, AC. Goes down just like that. And then we have the capacitor. Plus is on the one side, minus is on the next. Take a little brush or something to kind of clean up the electrolytic that's around there. I got a Q-tip here, that'll do just fine. And we'll put that part in. We'll solder them all in, same point. And then I'll cut the leads off. And then reassemble. See how we fare. There's your side, positive. There's your negative. Now these had heat shrink on them. Keep it bent away from that enough and you'll be fine. Put some hot glue there. You never have to worry about it. Or glue it down there. You'll be alright. Just want to see if I can tack this into place real quick before it moves. There. Finish that solder job up. It looks like crap. Alright folks, I'm going to cut everything off. I'm going to put the heat sink back on and apply power. Now we were looking at that MOSFET before and it rated 366 ohms. Now I'm back in the mega ohms, so that's good. I'm happy with that. We will take and attach some wires to it because I do not have the connector for this. I'll just solder some wires on the bottom. Yeah. Taking the heatsink off was pretty simple. Putting it back on was even simpler. Didn't need to take that off, so it's just good to go to take off the 2 screws over here, plus this 3 here. Pop your capacitor, change the 2 other parts out. Should be good to go. Let's just get this soldered up and powered up and see where we go. Okay, let's do the smoke test. Plug it in. And we'll measure the voltage. Okay, so far no booms. Let's see what happens. 24 volts. Probably not a good measurement because I'm not really on the pin. 23 point. That's switching pretty fast. Should still be pretty good. Should be good to go. I might need to take and change out a capacitor here. Help with filtration. That's 330 microfarad, 35 volt, which I don't have. I'm still gonna call this good. Good enough for me. That's all I have to talk about it with this thing here. Thanks for watching, guys. We'll see you next time. Please leave me a thumbs up and subscribe if you haven't. I try to do some things to help out in the world. We'll see you next time.